Okay, so I'm going to now do a few more infinite limits for you. The first one, you can see it here, it is the limit as x tends to 3 from the right of the function log of x cubed minus 27. Okay, well, first thing we should do, as usual, is ask ourselves, is this 3 here in the domain of this function? Well, when x is equal to 3, x cubed is 3 cubed, which is 27, and so 27 minus 27 is 0, and so if 3 were in the domain of the function, then we would be able to evaluate the log of 27 minus 27, which is to say the log of 0, and in fact, we can't do that. The log of 0 is not defined. Well, in case you're questioning that, we should do what we should always do when we're trying to deal with a log function, especially the limit of a log function. We should attempt to draw the log function. So here we are off to the side here. You'll recall that the log function, y equal to the log of x, it looks like this. Y equal to the log of x. So there it is there. That up a bit. There we are. And remember, the log of 1 is equal to 0. Okay, so as you can see, the log function, log x, it's only defined for x bigger than 0, and it's not defined for x less than or equal to 0. All right, well, so 3 isn't in the domain of the function. We can't just evaluate, but that doesn't mean that we can't say something about the limit. All right, well, the first thing we should notice is that we're letting x tend to 3, in this case, from the right. So what does that mean? Well, remember, x tends to 3 from the right means, of course, that x is tending to 3, so x is approaching 3, and also x is, for all x's we're concerned with, x is bigger than 3. All right, so if x is going to be bigger than 3, you might ask, how does x cubed compare with 27? Well, if x is bigger than 3, then we can say that the cube of x is bigger than the cube of 3, which is to say x cubed is bigger than 27. And if x cubed is bigger than 27, then if I subtract 27 from x cubed, I get a number bigger than 0. Just subtract 27 from both sides of this inequality up here, and you'll see that. All right, so what does this mean? This means that for all x's that we're considering when we take this limit as x tends to 3 from the right, well, for all x's that we're considering, x cubed minus 27 is going to be bigger than 0. So what does that mean? Well, if we look over here, that means that this argument here on the log function is tending to, well, as x tends to 3, as we said, from the right, certainly x cubed minus 27 is tending to 3 cubed minus 27, which is to say it's tending to 0. But also, for all x's that we're considering here, x cubed minus 27 is bigger than 0. So that means that for all x's that we're considering here, this x cubed up here, this x cubed minus 27 up here is bigger than 0, so we can say that this is actually tending to 0 from the right. All right, so finally then, for all x's that we're considering when we take this limit, this argument in here is going to be a number which is very, very close to 0 and also positive. So the question then is, what does the log of a very small positive number look like? And to see that, well, if we recall what the graph of the log of x looks like, we can answer that question. The log of a very, very small positive number is a very, very large negative number. And as we take logs of increasingly small positive numbers, we obtain increasingly large negative numbers. And so, as x tends to 3 from the right, our argument here tends to 0 from the right, and the log of these very small positive numbers that we're considering are becoming arbitrarily large and negative, and the answer here is, to our question, is minus infinity. All right, so that completes that problem there. All right, let's try another one. So now let's consider, so we should call this one B, the other one must be A then, the limit as x tends to 3 now from the left of the log of x cubed minus 27. All right, well, once again, 3 is not in the domain of this function, because when x is equal to 3, x cubed minus 27 is again 0, and we can't evaluate the log of 0. Our graph over here of log x, it is not defined at 0. Okay, well, what about the actual limit? Can we evaluate the limit of log of x cubed minus 27 as x tends to 3 from the left? Well, let's see. Let's just recall, what does it mean to say that x is tending to 3 from the left? Well, x tends to 3 from the left means, as we said above, that x tends to 3 and x is less than 3. But if x is less than 3, x cubed is less than 3 cubed, which is to say x cubed is less than 27. So what does that mean? X cubed minus 27 is less than 0. All right, that means then that for all x's that we're considering when we take this limit, x cubed minus 27 is less than 0, and we can't actually evaluate the log of a number that's less than 0. Right? The log function, there it is here, isn't defined for x less than or equal to 0, so we certainly can't evaluate this limit here, because when we attempt to evaluate this limit here, we have to be able to evaluate logs of x cubed minus 27 for x less than 3. In other words, if we wanted to evaluate this limit here, we'd have to be able to evaluate logs of negative numbers, which we can't, so we can say, in fact, that this limit quite simply doesn't exist. All right, so this one does not exist. Just write that. This one does not exist. Okay, well, let's try another problem. Okay, so let's see. We'll call this one part C. Okay, so this is going to be the limit as x tends to 3 from the left of the square root of 9 minus x squared, all divided by x minus 3. Alright, so as usual, the first thing that we should do is try to determine if 3 in this case is in the domain of this function. And if we check, well, when x is equal to 3, our denominator is going to be 3 minus 3, which is 0. Alright, so definitely not in the domain of the function. And let's take a look at what happens with the numerator in this case. When x is equal to 3, the numerator is root 9 minus 3 squared, which is to say root 9 minus 9, root of 0, which is 0. Okay, so this is a limit of type 0 over 0. Its value could be anything. It could be any number. It could be plus or minus infinity, or it may simply not be defined at all. Well, what we usually do when we see limits of type 0 over 0 is we attempt to somehow simplify the function whose limit we're trying to take, usually by trying to do some algebra. Well, in this case, what can we do? Well, we'll do the only thing that may seem natural, which is we'll look at that numerator there, and we see that there's 9 minus x squared. That is a difference of squares, so we'll find out if this will help, but it seems like a natural thing for us to do if we write this as the square root of 3 minus x, and we factor that numerator as 3 minus x times 3 plus x, all beneath the square root sign, and this over x minus 3. Alright, well, we might wonder what to do now. It seems that what we should probably try to do is somehow cancel, if possible, this x minus 3 in the denominator with something in the numerator. And here we have x minus 3, here we have 3 minus x. They look kind of similar. Let's see if we can first isolate this 3 minus x somewhat in the numerator, and then see what we can do to make x minus 3 look a little more like 3 minus x. Well, what you may be wondering though is, well, can we even take this limit as x tends to 3 from the left? In other words, for the x's that we're considering here, which is to say for x less than 3 and x close to 3, can we actually calculate this square root here in the numerator? Well, we can do that if what lies beneath the square root is a number that's greater than or equal to 0. We can't do it if the numerator is, if what's lying beneath the square root is less than 0. So let's just notice right now that x approaches 3 from the left means that x is, of course, approaching 3, and x is less than 3. So, because x is less than 3, subtracting x from both sides of this inequality, we get 0 is less than 3 minus x. Okay, calm down, dog. All right. Okay, so, as I was saying before the dog so rudely interrupted me, this means that for all x's that we're considering, x is going to be less than 3. Therefore, 3 minus x is, in fact, bigger than 0 for all x's that we're considering. And so, what lies beneath this square root here? This is going to be positive. 3 minus x is bigger than 0, and certainly 3 plus x is going to be bigger than 0 for x near 3, because x plus 3 is going to be close to, in fact, 3 plus 3, which is 6. Alright, so no problems with calculating square roots here. Note that if we were instead attempting to take the limit as x tends to 3 from the right, then for all x's we were considering, we would have had x bigger than 3. 3 minus x would have been less than 0. What would have been beneath the square root sign would have been less than 0. And so for all x's that we would have been considering, had we been attempting to take the right-hand limit, for all such x, what would have lied beneath the square root sign would have been a negative number, wouldn't have been able to take that square root. This function would not have existed for any of the x's that we wanted to consider, and so at this point we would be able to say that the limit did not exist, as we were able to do in part B above. But, good thing, for all x's we're considering here, x is less than 3. 3 minus x is positive. What lies beneath the square root is positive. For all x's we're considering, this function is in fact well defined. Alright, so now turning our attention to the limit, I want to try to isolate this 3 minus x a little bit, and to do that, let's just recall that the square root distributes across products of positive numbers. So if a and b are positive, the root of a, b is the same as, so am I running out of room there? It's the same as, this is equal to, root of a times the root of b. Alright, so I can distribute square root signs across products of non-negative numbers. I can't distribute, remember, square roots across sums. Alright, but square roots do behave nicely with respect to products. So that's what I'm going to do here. I'm going to distribute this square root sign across this product in my next line. Okay, so this is equal to the limit as x tends to 3 from the left of root 3 minus x times root 3 plus x. Alright, so that's good. And now, somehow, as we said, we're going to want to cancel this x minus 3, it would seem, with this root 3 minus x. The first thing that I'd like to see is not x minus 3, but 3 minus x. So I'm going to rewrite this as 3 minus x just by pulling a negative sign out. Alright, so this is equal to the negative of 3 minus x in the denominator. Distribute that negative sign through to see that, in fact, we have exactly the same thing as before in the denominator. And now, we can say that this is equal to, alright. So at this point, we can do some canceling by using laws of exponents if I want to write this as 3 minus x to the 1/2. Or, I can do what I'm going to do. I can write this, just rewriting the numerator again. I can rewrite this 3 minus x down here as the square of the root of 3 minus x. Alright, the square of the root of any non-negative number is just that number. Alright, so we can do that, and now I see root 3 minus x in the denominator and the numerator, and I can cancel. And in my next line, let's see what we've got. This is equal to the limit as x tends to 3 from the left of root 3 plus x in the numerator. I've canceled that root 3 minus x. I'm left with root 3 minus x. And I have a negative in the denominator, but I can put that negative upstairs if I want, just as well. And now we've done some canceling. Let's take a look at our limit again. What we should do is ask ourselves, is 3 now in the domain of the function that we're looking at? And, well, if you check, the denominator, as x tends to 3, is tending to root 3 minus x. Root 3 minus 3, which is 0. And the numerator is tending to root 3 plus 3, which is to say root 6 with that negative in front. So it looks like that. All right. So the numerator is tending to the negative root of 6, and the denominator is tending to just 0. 0 again isn't in the domain of this function, but now we know that the numerator is tending to negative root 6. I know that this should be an infinite limit. The limit should be either plus or minus infinity, which it is. We can't say yet. It depends on what side that denominator here is approaching 0 from. So let's think about that. And while we do that, let me see. I think I'm going to just erase this bit here. Somehow this does not want to erase. Oh, there, I did it somehow. Okay. So let's take a look. What's happening here? Okay, so we just said, as x tends to 3 from the left, our numerator is tending to negative root 6, and our denominator is tending to root 3 minus 3, root 0, just to say 0. And the question is it tending to 0 from the right or the left? Well, we already noted above that as x tends to 3 from the left, 3 minus all x's that we're considering are less than 3. So 3 minus x is bigger than 0. Positive square root of this positive number is bigger than 0 as well. So I can say that this denominator is tending to 0 from the right. Where did we say all that? We said it right up here. Okay. So now going down again. Now we have everything that we need to complete this problem. What can we say? Well, for all x's we're considering, the numerator is a number which is close to negative root 6. In particular, it's negative. And for all x's that we're considering, our denominator is a very small positive number. In particular, we have a negative number divided by a positive number. For all x's we're considering, this function here is going to be negative. So let's write that down, negative. And also, for all x's that we're considering, the numerator is close to minus root 6 divided by this very, very small positive number. We're going to have a very, very large negative number. The limit then of this function is equal to minus infinity. All right, as x then gets arbitrarily close to 3, with x less than 3, this function here, and therefore the function that we started with, is this function here is taking arbitrarily large negative numbers. The overall limit is minus infinity. Okay, that's all.